Hi, my name is Andrew Tam, and today I will be going over sine and cosine functions. You may remember from grade 10 what cosine and sine equations are, but if you don't, here's something to help jog your memory. In a triangle, there are 6 measurements you can have: side A, side B, side C, angle A, angle B, and angle C. However, in order for the sine and cosine equations to work, it has to be a right angle triangle. So we will be eliminating one angle, which will be C, because we're going to make it a 90-degree angle. In order to solve for a side or angle given 2 of 3 measurements, we can use the sine or cosine equations, which are sine theta equals opposite over hypotenuse and cosine theta equals adjacent over hypotenuse. For example, in this triangle, our theta would be angle A, and for sine, which is opposite over hypotenuse, it would be sine A equals A over C. And cosine, which is adjacent over hypotenuse, it would be cosine A equals B over C. Now that we've got the basics of cosine and sine equations down, we can move on to the key terms of cosine and sine functions. So first we have the cycle, a portion of the graph of the function from one point on the graph to the point at which the graph starts repeating itself. So a real-life example of this would be of someone riding a bicycle. One cycle would be equivalent to one full rotation of the wheel. Next we have the period, the number of degrees taken to complete one cycle. So following that same example, one period would be the time taken for one full rotation of the wheel. Axis of curve. This is the line that passes through the center of the function. So following that wheel example, the axis of curve will be where the axle is, because that is the midpoint from the top of the wheel and the bottom of the wheel. Amplitude. The distance to which a sinusoid rises and falls above and below its axis. And following that wheel, the amplitude would be the distance from the top of the wheel to the axis of curve, which is where the axle is, and from the bottom of the wheel to the axis of curve. Finally, we have phase shift. This is the distance the function has shifted horizontally from the parent function. So now we put those key terms into a graph. First off, we have our axis of curve. Since our maximum value is 1 and our minimum value is -1, that means the midpoint between those 2 points is 0, which is also our x-axis. Next off, we have our amplitude. Since our maximum value is 1 and our axis of curve is 0, the distance between those 2 points is 1. Also, since our minimum value is -1 and our axis of curve is 0, that distance is also 1. That verifies that our axis of curve is actually 0 and our amplitude is also 1. Then we have our period. Since our sinusoidal function starts at 0, goes up, down, and to 360, that means our period is 360 degrees. Since this also only shows up once, that means our cycle is only 1. Finally, for our phase shift. Since this is our parent function, that means our phase shift is not there. So we don't have a phase shift, and yeah. Now to put the cosine and sine functions into an algebraic form, this is how you would do it. Cosine theta equals A times cosine bracket K bracket theta minus D close bracket plus C. Sine is the same thing as cosine, just that you have to change cosine for sine. Below those two equations, we have their parent functions graphed. If you look closely, you'll notice that the cosine graph is very similar to the sine graph. The only difference is that it has a phase shift 90 degrees to the left. This will play a big part when you're graphing your own scenarios. Now you may be wondering what those variables were inside the two equations. Well, first off, we have A. This is the amplitude of our graph and can be calculated with the formula max minus min divided by 2. Next, we have the K value. This is the period of the graph and can be calculated with the formula 360 divided by your period. Next, we have the phase shift. This is the horizontal deviation from the parent function. Finally, we have C. This is the equation of the axis of curve. It can be calculated with the formula max plus min divided by 2. Now for a real-life scenario. So from watching that video, we can tell that the person was standing about 1 meter away from the ball and was throwing it consistently for about 3 times. So using that data, we can put that into a table of values, which will help us graph our equation. So at 0 time, the ball was 1 meter because it was inside the thrower's hands. And at 0.5 seconds, it was at the wall, and at 1 second, it was back in the guy's hands. So if he repeated that 3 times, so we repeat that 2 more times for a total of 3 cycles. So first, determine our A value. It is max minus min divided by 2. So our max was 1 minus 0 divided by 2, which goes 0.5. Next, for our K value, that is 360 divided by our period. That our period is about 1 second, so 360 divided by 1 equals 360. So that's our K value. Next for our D value, this is our phase shift. Since we started at 1, we don't really have a phase shift, so we put not available. And finally for our C value. Our C value is our axis of curve, and that equation is max plus min divided by 2. So our max is 1 plus 0 divided by 2 equals 0.5. So that gives us all our values for our cosine equation. So if we put that in, it would be cosine equals 0.5 cosine 360x plus 0.5. And that is our cosine equation. Now for our sine equation. Since we have our cosine function, we already have 3 of our 4 variables, those being our a value, k value, and c value. Now we need to find our d value. Since before we learned that our d value is our phase shift and that our cosine and sine parent functions are quite different, we can try to find it by first plugging in what we know into a sine equation, which is this. So if we were to graph that right now, we would find that the beginning of a cycle would not be at the y-axis. Our closest cycle would actually be negative 0.25 and 0. So we want to push that right 0.25 units, so one of the points is 0, 0. So in order to do that, we would add our d value as 0.25, giving us 0.5 sine 360 bracket x plus 0.25 close bracket plus 0.5. Now that, forgot to put s because that is sine, that would give us our sine equation. And just to make sure, I'm going to go on Desmos and graph both our cosine and sine equations just to make sure they're actually right. So after graphing both equations in Desmos, it's apparent that our equations are indeed correct. So now we're going to move on to changing our k value. If you remember from before, our k value is basically our period. So we need to either speed up or slow down what we're doing. In our case, throwing a ball. So in this video, I'm going to be throwing a ball slower, and I'm going to find the equation and graph it. So after analyzing that video, we can arrive at our table of values. At 0 time, the ball is at 1 meter. At 1 second, the ball is at 0 meters on the wall. 2 seconds, the ball is at 1 meter back in the hands, and we repeat that 2 more times for a total of 3 cycles. So, in order to find our a value, our formula is max minus min divided by 2. Our maximum value is 1, subtract 0, which is our minimum value, divided by 2, that gives us 0.5 as our a value. Now for our k value, we have to do 360 divided by our period, except this time our period is 2. So 360 divided by 2 equals to 180, and that is our k value. For d, so as remember from last time, our cosine equation, we don't have a d value, so we put not available. Finally, for our c value is our axis of curve, so that is max plus min divided by 2. So 1 plus 0 divided by 2 equals 0.5. Now that we have all 4 of our variables, we can put that into our equation. So cosine equals 0.5 cos bracket 180x plus 0.5. Now that is our cosine equation. In order to find our sine equation, the only thing that's different is our d value. So in order to find our d value for sine, we have to do our cosine of d, which is 0, minus period divided by 4. Since our period is 2, we do 0 minus 2 divided by 4. And that gives us 0 minus 0.5. And so our d value is negative 0.5. Now if we put that into our sine equation, that will give us s sine equals 0.5 bracket 180 bracket x plus 0.5 close bracket plus 0.5. And that is our sine equation. Now we have to put it into Desmos again, just to make sure we're correct. And yeah. So both of our equations were correct again. So now we're going to change the a value. If you remember from before, our a value is our amplitude. So that means we're going to have to move back and throw the ball again. So from looking at that video, we can tell our table of values. At 0 seconds, the ball was at 2 meters in my hands. At 1 second, the ball was at the wall at 0 meters. And at 2 seconds, the ball was back in my hands. So repeat that 2 more times and we get 3 cycles. So in order to find the algebraic form of this graph, we would have to first find the a value. So a is equal to max minus min divided by 2. So our max is 2, minus min, which is 0, divided by 2. That will give us 1. For our k value, that is our 360 divided by period. Our period is 2 seconds for 1 full cycle, so 360 divided by 2 equals 180. From before, our d value for cosine function is not available. And finally, our c value. Our c value is our axis of curve, so that is max plus min divided by 2. So 2 plus 0 divided by 2 is equal to 1. Now we plug those values into our cosine equation, and we'll get 1 cosine. But 1, that means that it will still be cosine. So cosine bracket 180x plus 1. Now to make the sine equation. So the sine equation would be cosine of d, which is 0, minus period divided by 4. So 0 minus 2 divided by 4, that gives us 0 minus 0.5, and that will give us negative 0.5 as our d value for sine. So we plug that in as s of x is equal to sine bracket 180 bracket x plus 0.5 close bracket plus 1. And that is our sine equation. Now for one more time, we're going to have to plug that into Desmos just to make sure we're correct. After graphing both equations in Desmos, both are indeed correct, and that will wrap up our lesson on sine and cosine functions. If you have any more questions, feel free to email me at tama6068@staugustinechs.ca.